Everyone, welcome back. So I'm going to start off with activity 2 from exercise 13. I hope you all had time to watch the introduction. Go ahead and share my screen. So here we're going to be looking at population size estimates. And like I said previously, we're going to be using the mark and recapture method, also sometimes referred to as the capture, mark, recapture method. So as you can imagine, we often cannot count every individual in a population, so we must come up with an estimate. When you do this, you will go and capture the or species organisms that you're interested in, and you will mark them as shown here. You want to make sure that the mark is small, um, but identifiable. And then you also want to make sure that it does not affect the organism's viability. So it's not destructive in any way. So a lot of times birds are marked like this, and you can see that these are marked here with some kind of coloring. So here are the steps of the mark recapture method. It's written out in a few different ways. I'm going to use this steps here to explain it to you, but if you want to read it in a paragraph form, feel free to use this slide for that. So the market recapture method. So step one, you're going to go out. So say you're a field scientist, you're going to go out and you're going to capture your individuals or your organisms, the species of interest. So I'm just going to say birds, very general right now. So you go out and you capture birds. Step two, you mark them. So you can mark them with one of those bracelets as shown in the previous slide. And then step three, you release them. So these birds that have those bracelets around them are now called your MT. So then you're going to go release them. You're going to wait a while. So step four, wait a while, let them, go back to their population, to their group, whatever, do their thing. And then step five, you're going to go back and recapture individuals. When you recapture individuals, you're going to have a few that already have that bracelet. These are your recaptured or MR. So you go recapture individuals, and few of those birds are already going to have the bracelet. So you count your recaptured. This becomes your MR. And then you're going to have a bunch of birds that don't have bracelets. These are called your newly captured or your UC. You will repeat this, and then you will plug these numbers in to your formula to get an estimate population size. We represent the estimate population size as N. Okay, so in activity 2, you could do this at home if you would like. You will get 500 beans. This is your population size, is 500. And now during our first sampling event, we're going to go ahead and get 50 beans. So 50 beans were captured, marked. They're marked with this black Sharpie, and then they're released back into the population. So we just did that step 1, 2, and 3. So our MT is going to be 50. So this is the table you have in your lab manual. So the actual number of beans in the beaker is 500. The total number of beans that were marked and released, so step 1, 2, and 3 is 50, so our MT is 50. So now during our second sampling event, so our second sampling event here, we are going to get 50 beans again. So we're going to go and grab 50 beans. From the 50 beans that we grabbed, 4 of those have already the mark on them as shown here in the black Sharpie. So this is our MR. So we put 4 here, and 46 of those do not have a mark. They have never been captured. They're newly captured beans. So this is going to be 46. Now we need to plug these numbers into our formula to estimate the population size. When we plug these numbers into the formula, you get 625. So you 50 for the MT, UC is 46, MR is 4, MR is 4. So you do 46 plus 4, that's 50. 50 times 50, 2,500 divided by 4, that's 625. Okay, so now let's say that we during our second sampling event, we were able to catch more individuals. So the first time you captured 50, um, step 1, 2, and 3, you went out and did the 50. But say that you didn't want to do to recapture 50 this time. Instead, you want to recapture 100. You're being a little bit more thorough in your investigation. So in your second sampling event, we went out and got 100 beans from that 500 bean beaker. When we did this, we saw that 9 were marked with the black Sharpie and 91 were unmarked. Now, what is our N? So our N would be 556. So you can see that when our second sampling, we did 50, our N was 625. That's pretty high. It's around the neighborhood of 500, but it's overshooting. We overshot our mark here. When we went out and did 100 for our second sampling, we were closer. We were at 556, still above the mark though. So now let's say we want to go out. So we did step 1, 2, and 3. We did our 50. We went out and captured individuals. We marked them with the black Sharpie and we released them and we did 50. But this time when we go out and so we wait a period of time, step 4, when we go out and recapture these beans, so at step 5, when we recapture, we want to do 150 instead of 50 or 100. So now we're just upping it. So pretend 50 and 100 never even happened. Like this is a new scenario, okay? So now when we go out and recapture these individuals, we go out and get 150. We count how many were recaptured. 15 were recaptured, and we count how many are newly captured, which is 135. When we plug this into our formula, 50 parentheses, open parentheses, 135 plus 15 close parentheses divided by 15, we get 500. So we can see that that is a much better or accurate estimate of our population. So this is going to, hopefully I don't confuse you here, but now your lab manual is asking, what if during our first sampling event, we had been able to catch more individuals? So remember, in these experiments, we went and captured individuals. We captured 50 beans. We marked them with black Sharpies and then we released them. So this whole time our MT has been 50. Well, what if our MT was 100? So what if when we initially went out to the field, we captured our beans, we decided to capture 100 beans. So we captured 100 beans, we marked all 100 beans and then tossed them back to the population, gave them some time to mingle. So we're at step 4, we're waiting a little bit. And now during our second sampling event, we go back and we get 50 beans. We get the 50 beans and we see that 9 were marked. So 9 were recaptured. And this is our MR. And we see that 41 are unmarked. These are newly captured individuals. This is our UC. So 9 were our MR, 41 are our UC. When we plug that into the equation, we get 556. So what did we see? Now, what are we seeing? What is a trend here? So I want you to ask yourself, when we are capturing more initially or even in our second sampling, what do you tend to see? Do you tend to see a more accurate representation of the population? Is the estimate better? So now what if during our first sampling event, we were able to capture even more individuals? Will we get a better estimate? So now we're doing 150 as our MT. So now we're going back to the beginning. Step 1, we go capture individuals. We capture 150 beans. We mark them. We mark all 150 beans with the black marker. We release them. 150 is now our MT. We wait a period of time, let them mingle. We go back and recapture individuals. When we recapture them, we recapture 50 beans. And so this is our second sampling event. We recapture 50 beans. And when we recapture them, we see that 15 were marked. So 15 were already have this black Sharpie on them. This is our MR. And we see that 35 are newly captured beans. So these are unmarked. This is our UC. So when we plug this into the equation, you see that our estimate is 500. So just take some time, work through those problems. Essentially, let me know if you have any questions about this. It's a little confusing in the beginning, but just really try to read it and take your time with it. It's pretty simple to do. It's just right now we're throwing a lot of variables in at once. But ask yourself which estimates of population size were most accurate. Was it more accurate to take a large first sampling, a small first sampling, um, a large second sampling? What was the most accurate in your opinion? And then there is also this simulation. If you want to practice some more, you can follow this link for a simulation. And that is it on activity 2.